So now we will discuss about the negation. The negation of P is written by the tilde or curl, which means it's not the case that P, or it can be read as not P. Negation is a denial. It contradicts the proposition. When the proposition is true, the negation of proposition is false. And when the proposition is false, the negation of proposition is true. So let's have an example of truth table for negation. We have proposition, negation of proposition, and negation of not proposition. Let's say our proposition is true. Since the proposition is true, the negation of the proposition will be false. And since the negation of the proposition is false, the negation of not proposition will be true.
Conjunction. Let P be the first proposition and Q for the second proposition. The operation AND is denoted by this symbol, the symbol for conjunction. Conjunction is a true functional connective. The proposition will be only true if both P and Q are true. So it means if one or both of the proposition is false, then the compound conjunction will be false. Let's take a look in this truth table for conjunction. The first example, the P is true as well as the Q. So the compound conjunction will be also true. The second example, the P is true while the Q is false. In order to satisfy conjunction, both P and Q should be true. So if the P is true and the Q is false, the compound conjunction will be false. Third example, the P is false and the Q is true, so the compound conjunction will be false. For the last example, the P is F or false and the Q is false too. So the compound conjunction will be false.
Disjunction. Let P be the first proposition and Q for second proposition. The operation OR is denoted by symbol V for disjunction. In order for the proposition P disjunction to Q to be true, at least one of the proposition is true or both of them are true. So, let's have an example. So the first is, if both P and Q are true, compound disjunction will be true. If P is true and Q is false, compound disjunction will be true. If P is false and Q is true, compound disjunction will be true. If both P and Q are false, compound disjunction will be false.
Conditional. This is written in the if-then format and it is symbolized by this symbol. So let P be the first proposition and Q for the second proposition. Conditional will be only false if P is true and Q is false. So let's have an example. If P is true and Q is true, the compound conditional will be true. For the second example, if P is true and Q is false, the compound conjunction will be false. If P is false and Q is true, the compound conjunction will be true. If both P and Q are false, the compound conjunction will be true.
Next is biconditional. For biconditional, it is written using if and only if, and this is symbolized by this symbol. Let P be the first proposition and Q be the second proposition. The biconditional will only be true if both P and Q are true, or both of them are false. So, let's have an example. This is the truth table for biconditional. As you can see here in the first example, if P is true and Q is also true, therefore our compound biconditional is true because both of our propositions are equal, which satisfy biconditional. Next, here, if P is true and Q is false, therefore our answer is false because they are not equal. One of them is true one of them is false. Next, if P is false, Q is true, our answer is still false because they are still not equal. For the final example here, if P is false and Q is false, our answer is true because both of our propositions are equal. So you can see here our answer is correct.